Hi, Geometry. Today we're talking about Unit 1, Lesson 16's notes on page 124 of our workbook on rotational symmetry. So let's read together at the top of the page. A shape has rotation symmetry if there's a rotation between 0 and 360 degrees that takes the shape to itself. So what we have right here on the side is a regular hexagon. So this is a regular hexagon. And the fact that it's regular is very important. It means that all the sides are the same length and all the angles are exactly the same degree. So what we're talking about with rotational symmetry is if I start rotating about the center, I'm going to hold my pen in the center very tightly. And if I start rotating, now my green hexagon on my patty paper is not lined up with my hexagon on my workbook. And if I keep rotating, eventually, it lines up again. Fantastic. And then I keep rotating, and now it's not lined up anymore. If I keep rotating, it lines up again. Fantastic. And so I'm trying to figure out how many times it might do that. So let's do it with our patty paper first. I recommend you put a dot at the top of your hexagon. We're going to rotate until this dot is back at the top of my hexagon. So here we go. I'm rotating. It's not lined up. It's not lined up. Oh, there it goes. Once it lined up. Let's keep going. My dot's not at the top. That was twice, and it lined up. Now it's not lined up again. It's not lined up again. It's not lined up again. And finally, that's the third time it's lined up. So let's keep rotating. It's not lined up. It's not lined up. That's the fourth time it's lined up. Finally, I keep rotating. I keep rotating. That's the fifth time it's lined up. And then if I keep going, my dot finally makes it back to the top. And that's the sixth time my hexagon has lined up with itself. So it does have a rotational symmetry. It lines up with itself 6 times. So how do I figure my rotational symmetry? I take the number of times it lined up and I divide 360 by that number. It lined up with itself 6 times. It has a rotational symmetry. 360 divided by 6 is 60 degrees. Every 60 degrees, my hexagon lines up on itself again. So almost if you could think about this as spokes on a wheel, I have 6 spokes on this wheel. And every time I turn from spoke to spoke, it lines up on itself again. And it does that 6 total times to come back around to its original position. So we can say it has a rotational symmetry of 60 degrees. That means it lines up on itself every 60 degrees. So at 60, once I've rotated 60 degrees, it lines up on itself. When I go 60 more, it lines up with itself. When I go 60 more from that, it lines up with itself. When I went 60 more from that, it lined up with itself. When I went another 60, it lined up with itself. And finally, when I got to 360 degrees, it was back to lining up with itself. Those are the 6 times it lined up with itself. Let's take a look at a square. A square is very similar. What do you think its rotational symmetry is going to be? Are you thinking 90 degrees? I love it. So let's look and see why it might be 90 degrees. Put a dot at the top and start rotating. So every time it lines up, count it. So as I go, it's not lined up, it's not lined up. So that's the first time. You might see not very well. I think it's because I drew my green one not good. And then again, it lines up a second time. It lines up a third time. And finally, I get back to the start. I know because my dot's on top again. It lined up 4 times. So I take my 360 degrees in my full rotation all the way around that circle, if you will, and I divide by 4. And so I find it has 90 degree rotational symmetry. So this has a rotational symmetry of 90 degrees. And that means that it lined up on itself after I rotated 90 degrees, then plus 90 more, 180 degrees, plus 90 more, 270 degrees, and finally plus 90 more. It wound back up on itself at 360 degrees. Those were the 4 times it lined up with itself. Let's take a look at another four-sided figure. In this case, it's a rectangle. So this rectangle does not have a rotational symmetry of 90 degrees. Sometimes kids think that that's what's going to happen, but let's take a quick look at this rectangle. What do you think it has? Was anyone thinking 180? So let's start this. So I'm going to rotate, and you see when I rotate 90 degrees, it's not lined up with itself. When I keep rotating 180 degrees, it's finally lined up with itself for the first time. And then I get back around 270 degrees, the next 90, it's not lined up, and finally get back around to 360 and it's lined up again. So this lined up with itself only twice. So if I think about 360 divided by the 2 times it lined up with itself, that would have a rotational symmetry of 180 degrees. That's actually called point symmetry. So the rotational symmetry is 180 degrees. That means it lined up with itself at 180 and at 360 would be the 2 times a rectangle lined up with itself. So a hexagon, this regular hexagon, and my square are regular polygons. If you have a regular polygon, a shortcut to think about, so if it's a regular polygon, this does not work for the rectangle, for an example. It wouldn't work for a rhombus, for example. It wouldn't work for a parallelogram. But if you have a regular polygon, equal sides, equal angles, congruent sides, congruent angles, then its angle of rotation is simply 360, a full circle, divided by the number of congruent sides that your polygon has. Sometimes you're going to see that we're not using a polygon. It's going to be a flower shape. And in your book, if I could flip to your practice, number 3, if I could flip up to this, sorry, moving my camera around, you'll see that it's not a square or a hexagon or an octagon. It's this flower petal shape. So let's take a look at a flower petal shape. So at the bottom of this page, that we were on, 124, I drew this flower petal shape. Now, these 3 flower petals are supposed to be exactly the same size, and they're supposed to be equally distanced apart. So really, my flower petals are mimicking, if you can imagine, I'll draw it very faintly, you can imagine, this is supposed to be mimicking an equilateral triangle. You can almost see that if I drew 3 lines through the middle of my petals, they touch the 3 vertices of an equilateral triangle. So that's what I'm supposed to be thinking about in my mind. So I'm rotating this. And keep in mind, this is a freehand drawing of mine, so it's not in the workbook. So it's not going to be as exact. Sorry about that. I was having camera issues. So if I draw my flower petals on this sheet of paper, and I start rotating, let's put a dot at the top so I know where I start. I see that they line up 1 time. They've now lined up with each other. And I go again. They line up a 2nd time. And now I see that my dot is finally back to the top and they line up a 3rd time. So my flower petals lined up with themselves 3 times, very much like an equilateral triangle would have done as well. So 360 divided by 3 gives them 120 degree rotational symmetry. So this has 120 degree rotational symmetry. And I also know that that's telling me that every 120 degrees it lines up. So at 120 degrees it lined up with itself, add another 120. So at 240 degrees it lined up with itself, and add another 120. And at 360 degrees it lined up with itself again. Thank you very much for watching. This is the end of lesson 16 notes video. I'm going to continue by doing a few practice problems. So at this time, you can stop the video. You can go do your practice 16. If you have any difficulty, why don't you come back to the video and I will explain a little more about a few problems. So continuing on with our lesson 16 practice, this particular flower petal, when you trace it on your patty paper, or if you want to start imagining rotating it, it's going to line up on itself once, twice, 3 times, and the 4th time is when it's going to come back to its original position. So 360 divided by 4 means it has rotational symmetry every 90 degrees. So this has 90-degree rotational symmetry. This question doesn't ask just what's its rotational symmetry. It says select all angles. Let me move this down. Select all angles of rotation that produce the symmetry for this flower. So I'm going to use the 90 to help come up with all of them. So my first one occurred at 90. The next time it lined up on itself, I have to add 90 more, would be at 180. The next time it lined up with itself, let's add another 90 to that. That would be 270. And finally, add my last 90, and I'm back to 360 degrees where I started. So I look at my selection choices, and I see my 90. I'm going to circle that. I see my 180. I'm going to circle that. And I see my 270. 360 is not mentioned, so I'm just going to circle those 3 right there. So let's take a look at number 7 on the back right here. I want to match each directed line segment with the translation. So the directed line segment right here, which we also call a vector, I want to match each of these with which translation it goes with. So again, I'm moving from polygon P to polygon Q. That's my blue triangle to my green. So I'm moving from my original, which is my blue one, to my green one, which is my image. I could draw in my directed line segment, but be careful. I can't match up those 2 vertices. They don't go together. I have to match up the vertices that would be corresponding. Those would be the vertices that go together. So if I draw in my vectors, I can see I have a vector, a directed line segment, that's going down to the right, and this is the distance that it would be. So I've got my direction and distance. Certainly looks like W. It looks like W down here, my 3rd choice. Let me label this A, B, C, D. I like matching a little better than drawing lines. It looks like this goes with A. And up here, I'm going to write that this goes with directed line segment W. I'll put a little W right there. So I can look and I can see that it moved down to the right about this distance. If you wanted to, you could verify even further. There's no other down to the right choices, so it was really a process of elimination, but I could measure and verify to myself that that is the correct one. So if of my 4 translations, there were 2 going down to the right, and I wasn't sure which one to pick, I could measure, and that could help me out. And that's how I would then process the last 3. Thank you very much.